All right, hello students, and welcome to my first video that I'm making in the new decade. I'm going to try to keep this as short as possible. I wanted to just make a video on how to universally solve kind of these scientifically worded math problems. So basically word problems, and hopefully you can use this skill across the board, but I'm going to use what we're learning about right now. So if you haven't learned about the wave speed equation yet, in the other Edpuzzle videos I've assigned, please go back and do that first, or you probably won't understand what equation I'm using. So let's take a look at this problem. So what is the frequency of light that has a wavelength of 550 nanometers? So this problem is actually really not that hard. It's just that when students read it, they freak out because there's all these words, and I get it. So let's just break it down. So the first skill you should do, that you should use when you're doing a word problem like this, is look for words that you know or that you've seen before. So without even reading, when I do these kind of problems, I don't even really read them for their context. I just say, okay, I have a frequency, and I know it's light, so we know that we're talking about frequency and light, and then I see wavelength. I also have some units here, so that's going to throw a little curveball in for us. But anyway, so I have frequency, light, and wavelength. Do we have an equation that relates those three things? And the answer is yes. It's the equation we just learned about. So it's wavelength, right, times frequency equals c, the speed of light. So now I say, okay, so I'm given a wavelength of 550 nanometers. Now the trick here is that and this is the one thing that you could do a bunch of these problems, but and they can become really easy, but the one thing that might still throw you off is the units. And so I showed you guys a video on how to convert units, the King Henry died drinking chocolate milk. And you can also use Google to help you out with this. But basically, obviously you won't have Google on a test, so you just kind of have to know how to do this through practice. But we know that this equation uses the units for wavelength in meters, frequency is hertz, and the speed of light is in meters per second. Now, this unit here, not nanometers, is obviously for wavelength, and we know wavelength is this lambda here. This is not in meters. So the very first thing we have to do is take this from nanometers and move it to meters. So I showed you guys another Edpuzzle video, and you might want to watch that first if you didn't yet, on how to convert. Okay, convert different units. And I use what's called a bridge. So in a bridge, you always just take whatever number is given to you, and we put that up in the left-hand side. We say, okay, that's nanometers. And we want to get to meters. You can also use the King Henry died drinking chocolate milk. The only problem is nanometers is not in that saying. So nanometers, you're going to have to look up. So if you look up on Google the conversion, so how many nanometers, I'm actually doing it right now, are in a meter. And when I look that up on Google, it's 1.0 times 10 to the 9th. And that's written as 1e plus 9, which is the same as 1.0 times 10 to the 9th. So we know there's 1.0 times 10 to the 9th, so that's 9 zeros away from nanometers to meters. So this is nanometers to meters. So when you go diagonally, it's division. So all we're going to do is do 550 over 1.0 times 10 to the 9th. And hopefully you guys saw how to write that in your calculator, and there's another Edpuzzle on how to do that. So 550 divided by 1.0 times 10 to the 9th, and sorry, that is a 1.0, it's not a 10. And what happens when you divide those is these units cancel out, and you're left with the units in the upper right, which is meters, which is what we want. So if I take my calculator really quick, I do 550 divided by 1 EE9, I get 5.5 times 10 to the negative 7th. And that's now in meters. Okay, so now we're on to our next part of our problem. So it's asking, what is the frequency? Okay, so this is the part I really wanted to show you guys, so really tune in here. Once we have our meters, the question it's asking is, what is frequency? So that's the unknown. So what I want you to start getting in the habit of is whatever question it's asking, you put a question mark over it. So it's asking for frequency, so that's going to be our unknown. So when I write out my equation, okay, wavelength, instead of frequency, I'm going to put a question mark. You could also put a variable like x if you really wanted to, but a question mark makes it a little easy to understand. So we have wavelength times this question mark equals c, and the question mark is what we're going to solve for. So if you're stuck here, then the next step is to see what they give you. So we already know that they gave us 550 nanometers that we had to convert to 5.5 times 10 to the negative 7th. So that's what would go here. So rewriting this, let me give myself some space here, we would have 5.5 times 10 to the negative 7th meters, and we'll put that in parentheses, times our question mark, because that's what we're trying to solve for, equals c. Okay, and so if you've ever taken algebra before, you say, okay, wait, what the heck? How do I solve for two variables, c and question mark, when I'm only given one number over here, right? So the answer is, well, we actually are given c, because you couldn't do that. We would need this other variable here. So we know that c is a constant, 3.0 times 10 to the 8th. So now we have two knowns and we're solving for one unknown. And I showed you guys an Ed puzzle on how to do this. So you guys know, hopefully now, and if you didn't watch that one yet, you should watch that now, that we divide, in order to get rid of this side, we divide it by itself. And you don't really actually have to do anything because that's just 1, right? And whatever we do to one side of the equation, we do to the other side. So the answer, and I'm not even going to calculate this because you can go ahead and do it, but if you got to this point, 3.0 times 10 to the 8th divided by 5.5 times 10 to the 7th, then you would get the right answer. But that's not even really what I care about. I want to go back and just reiterate the steps that we used here. Okay, so when we're dealing with this problem, what is the frequency of light that has a wavelength of 515 nanometers? What are the steps we need to use? Well, step number 1 is look for all of the things that you've seen before. Frequency, light, wavelength. And then think of an equation, that would relate all of those. Okay, and in this case, we have that equation. Wavelength times frequency equals the speed of light. And then take what they've given you. Okay, they've given us a wavelength. We had to do a quick conversion, right, to get it into, so maybe the next step would be check that your units of what they're giving you match the units of your equation. So in this case, it's meters, hertz, and meters per second. Well, nanometers had to be converted to meters in order for us to use this equation, but we can do that, right? So then once you've done that, you've realized what they've given you, and we've realized what they are asking for, then we just need to make sure that we filled in for all of our other knowns. And this is where people get stuck because you forget that this is a constant. So don't forget, c is a constant. And whenever you're using any other equation, try to remember what your constants are, or else you'll get stuck and you'll be like, well, I don't have the speed of light. But you do, right? Because you just have to know it. You can always look these things up too when you're working on the worksheets, but on a test, either I would give them to you or you would need to know it. But anyway, I just wanted to, what I really cared about in this video was breaking down how to do word problems. Look for the words they gave that you know, relate it to an equation, check that the units match the equation, figure out what they're asking for, and then plug in what you know, and then solve for that unknown. So in this case, we have one unknown with two knowns, and we can solve for that. Okay, so if some of this doesn't make sense, you may need to go and review the other videos, but other than that, that's it for me. And good luck.